Alright, so this video is going to be on integrating power series. So just as we were able to take derivatives of power series, now we're going to be able to integrate them. This is going to further help us express more functions as power series. So we have f of x being expressed as the sum from n equals 0 to infinity of c sub n times x minus a to the n, right, our general power series formula. Okay, now if we take an integral here, we take an integral of f of x dx. This is now equal to our constant c, probably the most different thing about the integrals compared to the derivatives here. Otherwise, it's, not much different. You have your c sub 0 times x minus a plus you have c sub 1 over 2 times x minus a quantity squared plus c2 x minus a to the third power over 3, and so on. Okay, and that is going to be equal to the sum from n equals 0 to infinity of, now we're going to get a c sub n times x minus a to the n plus 1 over n plus 1. Oops, and I forgot our c plus, okay? Because the c is not really a part of everything here, okay? The c is its own thing. Now we're still starting at the n equals 0 term, okay? Because this didn't go to 0, okay? This didn't go to 0. It looks like, yeah, I got bumped up 1, but don't be confused with that because the c is outside the summation, okay? So this is our n equals 0 term. This is still the term that we're starting at. The reason why we bumped it up for derivatives was because this term went to 0, so there was no use in starting from n equals 0, okay? So this is now your little formula, your general formula for taking an integral of a power series. All right, so let's do an example of when we should integrate a power series. So we want to describe this function, natural log of 1 plus x, as a power series. Well, what we can do to start off here is take a derivative. Okay, I know that's weird because we're talking about integrating power series here, but we're actually going to take a derivative to start. Now we know that the derivative of this will be 1 over 1 plus x. Said another way, this is 1 over 1 minus a negative x, which we can write as the power series, the sum from n equals 0 to infinity of negative x to the nth power. Why is this good for us? Well, if we integrate these things, well, we're going to get back to that natural log of 1 plus x, and now we'll have a power series that can represent that. Okay, so let's take a integral of 1 over 1 plus x dx, and that will be equal to the integral of the sum from n equals 0 to infinity of negative x to the n, and we'll have a dx on the outside there. Okay, now one thing to note is that you can move this integral in and out of the sum, or in and out of the sigma. Okay, it doesn't really matter. You can if you want, if it makes your life a little easier, I guess. So your integral of 1 over 1 plus x dx, that is natural log of 1 plus x. Now when we take the integral of this sum here, okay, the series, what we get is c plus, well, this is now the sum from still n equals 0 to infinity. Okay, the index doesn't change. And, well, now you have a negative x to the n plus 1, and this is going to be over n plus 1. But you also are going to have a negative 1 out front because you have a negative x and not an x. So you're going to have a negative 1. All right, cool. So now what do? Well, we need to be able to find c. Okay, to do that, well, we have an x on this side, an x on this side. So if we plug in x equals, well, let's plug in x equals 0. Okay, plug in plug in x equals 0, we have a natural log of 1 is equal to c plus the sum from n equals 0 to infinity of, we have a negative 1 times 0 to the n plus 1 power over n plus 1. Now what we know is that this is going to be 0 and this is going to be 0, so c is going to equal 0 in this case. Okay, so we know now that we have natural log of 1 plus x equal to the sum from n equals 0 to infinity of negative 1 times x to the negative x, to the n plus 1 over n plus 1. One last thing here, we can simplify this a little bit by taking out that negative 1. We could have done that to start off with, to be honest, but whatever. So we get the sum from n equals 0 to infinity of, we have a negative 1 times negative 1 to the n plus 1 times x to the n plus 1 over n plus 1. All right, now we can write that as natural log of 1 plus x equals the sum from n equals 0 to infinity of negative 1, well, what power is this going to be to? This will be negative 1 to the n plus 2. That's also the same thing as saying negative 1 to the n. They do the exact same thing. Okay? Adding an even number will do nothing to change what's going on here, okay? Negative 1 to the n. It's going to be the same thing as negative 1 to the n plus 2. All right? And you can check that if you're still unsure about that. So we have a negative 1 to the n. Now, we also are going to have a x to the n plus 1 over n plus 1. So yeah, right there, that's our power series, and that's how we integrate power series in order to describe a function as a power series. Okay, so that's the whole purpose of us integrating power series right now. Okay, so that's going to do it for this video.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for sequences and series and the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.